We know how sounds are constructed on wavefront. Suppose this is a plain wavefront. It's the first sound, this is the second sound, then third sound, fourth sound, etc. That is the wavefront. This wavefront can be divided into a number of sounds. Each sound with a path difference. This is B, the distance between the center of wavefront and a point P, and sounds are constructed based on the point. Again B plus lambda by 2, etc. That is the phase difference between two sounds corresponds to lambda by 2. Phase difference lambda corresponds to path difference lambda corresponds to a phase difference 2 pi. That is, if this is a wave, the wavelength is lambda, the total angle is 360 degree, that is 2 pi. The path difference lambda corresponds to a phase difference 2 pi. That means a path difference lambda by 2 corresponds to a phase difference 2 pi by 2. That is lambda by 2 corresponds to a phase difference pi. And phase difference pi means just the opposite phase. 180 degree phase difference means just the opposite phase. That is, if the amplitude from first sound is D1, second sound will be having an out of phase amplitude, that is minus D2. The sign will be minus. Again, the third one will be out of phase with second, that is minus into minus, that is plus D3. Again, the fourth one will be out of phase with respect to 3, that is plus into minus, minus D4. Fifth one will be out of phase with respect to this minus, that is plus D5, minus D6, etc. That is amplitude from each sound. This is amplitude from first sound, this is amplitude from second sound, and this is amplitude from third sound, etc. And here we are going to explain the rectilinear propagation. Rectilinear means the straight line propagation with the help of sound theory, accepting the wave nature of light. That is, light is a wave, means it should be traveling like a wave. But what we experience normally when we are having a large object, a large opaque object, we are not observing diffraction. We are getting the darkness like this. That is, light is traveling, that means light is traveling like a straight line. And again, we are getting this diffraction effect if the opaque object is very small. And here we are going to explain why this happens. That is, when the opaque object is very small, we get diffraction, and when the opaque object is very large, we will feel like light is traveling in straight line. That means we are going to explain the straight line or rectilinear propagation of light accepting the wave theory. And for that we are using the concept of sounds. And we know if the amplitude from the first sound is D1, the amplitude from the second sound is minus D2, plus D3, minus D4, etc. plus D5, etc. then write this, we can write d1 as d1 by 2 plus d1 by 2 minus d2 plus, write this d3, we can write d3 as d3 by 2 plus d3 by 2 minus d4 plus d5 by 2 plus d5 by 2 minus etc. That's equal to d1 by 2. Take these three terms, d1 plus d3 by 2. That will be approximately equal to d2. Average of d1 and d3. d1 plus d3 by 2. That will be approximately equal to d2. That is, this will be d2 minus d2, which is equal to 0. And this term, d3 by 2 minus d4 plus d5 by 2. Average of d3 and d5 will be equal to d4. That is, this term will also be 0. d4 minus d4, 0. Plus etc. etc. like that. Every term will be 0. When moving on to higher order term, the amplitude will be less. The amplitude will be maximum from the first zone. It will be decreasing, then further decreasing, then yet another decrease, like that. And finally it will be very least. It will be least. The amplitude will be least. That is, now the sum is equal to d1 by 2. That is, the amplitude, total amplitude due to different zone is equal to half of first zone. That is intensity. Intensity is the square of amplitude. Intensity is d1 square by 4. And this happens when all the zones are present. If all the zones are present, we are getting this value. That is, the total amplitude will be equal to the half of first zone, and the intensity will be square of this term. Square of amplitude is intensity. Intensity is proportional to d1 square by 4. And in the case of, and we know the area of zone. Area of zone we have calculated as pi b lambda. Lambda is a wavelength of light, and we know the wavelength of light is very small, in nanometer range. That is, each zone is having very small area. Zones are very small. That is, even if the object is small, too much number of zones will be blocked from the incoming wave, because these zones are having very small area. അപ്പോൾ സോണിൻ്റെ ഏരിയ വളരെ കുറവായതുകൊണ്ട് ഒരു ചെറിയ ഏരിയ വേവ് ഫ്രണ്ട് എടുത്താൽ തന്നെ അതിൽ ഒരുപാട് സോണുകൾ കാണും. അപ്പോൾ ഏറ്റവും കോൺട്രിബ്യൂഷൻ വരുന്നത്, ഏറ്റവും മാക്സിമം കോൺട്രിബ്യൂഷൻ ഫസ്റ്റ് സോണിൽ നിന്നാണ്. ഏറ്റവും ആംപ്ലിറ്റ്യൂഡ് കൂടുതൽ ഫസ്റ്റ് സോണിനാണ്. പിന്നെ സെക്കൻഡ് സോൺ അതിനേക്കാൾ കുറവായിരിക്കും, മൂന്നാമത്തേത് അതിനേക്കാൾ കുറവായിരിക്കും, നാലാമത്തേന് വളരെ കുറവായിരിക്കും, അങ്ങനെ വളരെ കുറഞ്ഞു വരും ആംപ്ലിറ്റ്യൂഡ്. ഒരു ഒബ്ജക്റ്റ് ചെറുതാണെങ്കിലും കമ്പാരിറ്റീവ്ലി സ്മോൾ ആണെങ്കിലും ഒരുപാട് സോണുകളെ അത് ബ്ലോക്ക് ചെയ്യും. ഇൻകമിങ് വേവ് ഫ്രണ്ടിൻ്റെ ഒരുപാട് സോണുകളെ അത് ബ്ലോക്ക് ചെയ്യും. അതായത് മെജോറിറ്റി കോൺട്രിബ്യൂഷൻ വരേണ്ടിയിരുന്ന ആദ്യത്തെ സോണുകളെല്ലാം തന്നെ അത് ബ്ലോക്ക് ചെയ്യും. ആൻഡ് വാട്ട് വി ഒബ്സർവ് ഈസ് ഡാർക്ക്നെസ് ഡിപ്പെൻഡിങ് അപ്പോൺ ദ സൈസ് ഓഫ് ഒപ്പേക്ക് ഒബ്ജക്റ്റ്. എന്താണ് ഒപ്പേക്ക് ഒബ്ജക്റ്റിൻ്റെ സൈസ്, അത്രയും എമൗണ്ട് ഓഫ് ഡാർക്ക്നെസ്. And if the object is very small, അപ്പോൾ എത്ര ചെറുതെന്നുള്ളത് ഡിപ്പെൻഡ് അപ്പോൺ ദ വേവ് ലെങ്ത് ഓഫ് ലൈറ്റ്. The wavelength of light is very small. That is, the size of the object should be comparable with that of wavelength of light. അപ്പോൾ അത്രയും ചെറിയ ഒപ്പേക്ക് ഒബ്ജക്റ്റ് അല്ലെങ്കിൽ അത്രയും ചെറിയ സ്ലിറ്റ് അങ്ങനെയാണെങ്കിൽ മാത്രമേ ഡിഫ്രാക്ഷൻ ഒബ്സർവ് ചെയ്യത്തുള്ളൂ. അതർവൈസ് we experience the rectilinear propagation of light. And here we have used the wave theory. Wave ഫ്രണ്ടിനെയാണ് നമ്മൾ സോണുകളായിട്ട് ഡിവൈഡ് ചെയ്തത്. That means we have successfully explained the rectilinear propagation accepting the wave theory using the concept of zones.